Wetlands are the world's fastest disappearing ecosystems. They are disappearing 3 times faster than forests. Many plants and animals found in wetlands are threatened with extinction. In Poland, wetlands still made up a significant part of the country in the mid-20th century. Looking back historically, it has to be acknowledged that no prudent action was taken with regard to these areas. Land reclamation measures in the last century, which consisted of draining and enlarging areas for agricultural production, disturbed water relations and thus the ability to retain water naturally. Wetlands. Marshes are most often formed in shallow water conditions when drainage is impeded by depressions in the land. It is good if they are fed by melting snow or rainfall, but this is occurring less and less frequently. Sometimes marshes are also created by the terrestrialization of water bodies. Winter. As far as the eye can see, a space covered in white fluff. Snow. Good thing it's here. Recently, it has become increasingly rare in the lowlands of Central Europe. It is a very important precipitation from which everything begins. The lives of thousands of creatures depend on its occurrence. We call them bogs, quagmires, and swamps. They used to be treated as wastelands of no great importance. Today, however, their role has completely reversed, and they are priority habitats. Most of them are located in forested areas, or are directly adjacent to forests. Wetlands in Poland account for 14% of its area, of which 4% is occupied by peatlands. They are our greatest allies in the fight against climate change. They cover just 3% of the surface of all the continents and store twice as much carbon as all the forests on the planet. Wetlands have an important hydrological function. They counteract flooding by absorbing water like a sponge and storing it in huge quantities, and distributing it to adjacent areas. They also filter and purify water of heavy metals and biogens such as fertilizers. During hot weather, wetlands lower the surrounding temperature as a result of using energy in evaporation. This energy is taken in the form of heat from the surrounding environment. Wetlands interact very positively with the areas around them, including forests, and are a home to many organisms. The destruction of these habitats contributes to a reduction in biodiversity. From as early as mid-March, it is possible to observe spectacular mating events for frogs from the brown frog group. They take place in shallow, sun-warmed reservoirs. The males call the females with characteristic sounds. They are easiest to observe at this time of year. Among the numerous common frogs, the strikingly colored male moor frogs are perfectly visible at this time. This color only persists during the short-lived mating season. The females lay clusters of scoots, from which the tadpoles soon hatch. They grow quickly, but apart from the predators lurking about, it is the drying out of reservoirs that most threatens their survival. Infrequent rainfall and land reclamation are not conducive to prolonged water retention. This is the main reason for the drastic decline in the numbers of all amphibians that has been evident for years. Peatlands have a remarkable ability to store water in the environment. This is all due to peat, a sedimentary rock made up of dead, undecomposed plant remains. Peat is formed in bogs under anaerobic conditions. Among the peat-building plants, the most well-known are the peat mosses. They have the ability to store water in their tissues. Some species can store 20 times their own weight. They have specialized specific water-bearing cells for just this purpose. Wetlands provide invaluable storage for rainwater and snowmelt. It is estimated that a high proportion of dense wetland complexes in a river catchment can reduce flood waves by up to several tens of %. Peat growth is very slow and averages about a millimeter per year in the temperate climate zone. It thus takes up to 1,000 years for a meter-thick peat to form. A characteristic feature of peatlands are the very small but showy-looking sundews, which readily grow in association with peat mosses in heavily moistened areas. In strongly acidic and poor soils, they make up for nitrogen deficiencies by capturing small insects which are then digested. Insectivorous plants, as well as characteristic animals, build up the extremely diverse world of the peatland. These are often unique, very narrowly specialized species not found elsewhere. The undisputed king of the wetlands is the elk, which are increasingly numerous here. On warm, sunny days, European pond turtles can be seen basking in the sun. These relicts of bygone times are threatened not only by habitat loss, but also by increasingly numerous invasive species, such as the red-eared slider turtle, which is effectively displacing the native species from their habitat. Turtle egg deposits are also plundered by other unwanted visitors, such as the common raccoon dog, Nycturetes, or the raccoon, Procyon lotor. The latter also contributes significantly to the destruction of nesting birds, and not just wetland birds. It is a specialized predator that can swim well and climb trees brilliantly. The hare's tail cottongrass, Eriophorum vaginatum. It is a fairly common plant in peatlands. Its snow-white down is an excellent flight apparatus for the tiny seeds attached to it. Marshlands and wet meadows are home to many of our native orchids. Most of them are plants that are disappearing from our landscape with the transformation of the environment and the disappearance of traditional extensive farming methods, mainly pastoralism and meadow farming. Wetlands are also home to a variety of dragonfly species that are very sensitive to ecosystem changes. The development of their larval forms takes place in the water and lasts for several years. During this time, the reservoir cannot dry out. Land reclamation, runoff from fields or deforestation surrounding their habitat can lead to the complete extinction of some species of these remarkable insects. Among birds, the most distinctive and at the same time perfectly specialized for life in the harsh environment of wetlands are the representatives of Scolopacidae, Rallidae, and Charadreidae. They feed on invertebrates and mollusks, which are abundant in such places. They also find excellent conditions for mating and breeding here. Wetlands adjacent to marshes are so-called marsh buffer zones. They often separate agricultural areas from wetlands, thus protecting surface waters from pollution runoff from fields. By preserving and restoring marsh buffer zones, we can stop fertilizer runoff and thus inhibit eutrophication. The fertilization of adjacent watercourses and reservoirs in the long term results in their overgrowth and degradation. The lush vegetation of swampy areas, which is adjacent to water-filled areas or riverbeds, also significantly reduces the speed of the flood wave, which reduces the effect of bank erosion. Extensive wetlands have the ability to shape the local climate. Evaporating water absorbs large amounts of heat energy, thereby lowering the surrounding temperature. In the vicinity of wetlands, the microclimate is therefore wetter and also cooler. In this way, wetlands have an impact on the regional water cycle. Progressive climate change is rapidly and significantly altering the living conditions to which we have become accustomed. Marshes can help slow down this process thanks to their incredible carbon storage capacity. The carbon stored in peat comes from the atmosphere. The plants growing in the peatland take in atmospheric carbon dioxide and store it in their tissues, and these turn into peat when they die. Carbon locked up in a peatland cannot return to the atmosphere as long as the peat is constantly saturated with water. Depending on the climate zone, 1 hectare of bog ecosystem stores several to tens of tons of carbon dioxide per year. By reducing atmospheric carbon, marshes have a cooling effect on the environment in the long term, like giant land-based air conditioners. The most common cause of wetland degradation is inadequate water conditions. Across Europe, as much as 60% of peatlands have been drained. Drained decades ago, peatlands reverse a process that has been going on for millennia, emitting stored carbon dioxide back into the atmosphere. In Poland, nearly 85% of all peatlands have been drained, mostly turning them into meadows and pastures. Drained marshes emit an amount of carbon dioxide equivalent to 10% of our total greenhouse gas emissions, of anthropogenic origin. Drained peatlands also contribute to fires, releasing even more carbon dioxide and other greenhouse gases into the atmosphere. In Poland, this is a marginal situation, but globally it is a big problem, especially in Siberia. In order to prevent the decline of wetlands, it is necessary to protect all those still well preserved, as well as to improve the condition of degraded peatlands that are still of natural value. It is also important to stem the outflow of water from heavily drained wetlands. Re-wetting them involves building levees on drainage ditches or completely filling in the ditches. Such activities are currently being carried out all over the world. For years, many projects have also been carried out in Poland. Beavers play a huge part in the process of restoring wetlands, creating bodies of water that give rise to wetland biotopes in an ecological and economical way. Unfortunately, beaver activity does not always go hand in hand with human interests. We can divide wetland ecosystem protection methods into active protection, part of which is the aforementioned restoration of degraded peatlands, and passive protection. Active protection aims to stop or reverse the process of secondary succession towards forest ecosystems. It consists of mowing wet meadows, removing tree and shrub overgrowth from open peatlands, grazing animals, or, for example, sustainable forest management of swampy forest. One form of active protection is so-called nature restoration. That is, the active support of the regeneration process of an ecosystem disturbed or destroyed by man. Wetland restoration involves, among other things, blocking the outflow of water from peatlands or revitalizing oxbow lakes and floodplains. For some wetlands, passive protection, that is, simply leaving them alone, is recommended. This applies to ecosystems that have been not transformed by man. Passive protection leads to the preservation of natural ecological processes in the wetland. Sustainable forest management favors the preservation of these water protective areas, which has a positive effect on both the productive role of the forest and the protection of extremely valuable natural habitats. Wetlands are crucial in halting adverse climate change. We should look at every such point on the map of our immediate neighborhood and our country as something priceless. Systemic solutions are needed, but also extensive educational efforts, so that everyone sees the benefit in protecting wetlands, crucial to the future of our entire planet.